Hey, how you doing? Mr. H here. We are officially into our last unit together. I don't know if to cheer or to shed a tear here. I don't know. Here's the good news. This straightforward is probably going to be, I hesitate to call it the easiest section we do, but it kind of is. It's where the least math work is involved and mainly just kind of understanding some ideas. So if you're more of a person who can take facts and just kind of remember them and stuff, this is going to be right up your alley. So we are into our stats and probability section here, and we're going to start with experiments, surveys, and observational studies. So, if those marketing people out there, those people who are trying to figure out, why do people do things and stuff like that, this is right up your alley. So here's the three things we're going to be looking at today. We're going to be looking at surveys. It's a way of figuring out info from a population or a sample of the population. We've all done surveys. We do a ton of them here at school most of the time during the year. Election polls, you saw those before. There's polls that ask here about how things are at the school climate, things like that. We just kind of want to get a feel for an opinion. An observational study takes that a step further. Okay, we even changed the names here. We call it an exam, where we check out individuals, but we're not trying to influence the results. So we're not going to tell somebody what they think. We're not going to just pick from people that we think the same as we do. The example is a good one. If you have a group of 100 people and 50 have been taking a treatment, 50 haven't been. So you're looking to see, does the treatment work for this particular, disease? Does this particular drug work? Does this particular way of studying work? And you have one group that does it and one group that doesn't, and then you just kind of watch them. Okay, you're not doing anything to them or anything like that. Okay, now then the experiment, probably know this more from science class, or maybe if you've had an illness or know somebody with one, they've done something experimental to see if it helps them. You're intentionally doing something. Okay, so let's take a peek here, especially with observational study and experiment, on what the main difference is. Observational study, no attempt to influence. You're strictly watching. Watching only, okay? An experiment, you're intentionally doing things and then observing what's going on, okay? Doing things. Making changes. So you're directly trying to affect what's going on in that human or that animal or whatever it happens to be. So again, studying the differences between two groups of people, one of which receives a treatment, so maybe it's a new drug, the other receives a placebo, which is called like a sugar pill or something. They're not really getting the drug, and so we're going to see, do these people change more or less than the others? And we check. And then within these things, within these experiments, not so much with the observational studies, is there a bias where there's an influence of one group over another? So for instance, surveying only students in AP Calc about how they enjoy math. Well, they're probably going to enjoy math since they're going to the highest level. If you ask that same question of students who are repeating Algebra 1, you'd probably get a much different answer. So you've got to make sure that you're getting little pieces of everybody in here to make sure that bias isn't there. Okay, so now that we got that out of the way, let's figure out if some of these actual situations are an experiment or an observational study. I'm going to move myself one more time here. Find 20 adults. I almost said just adults. That would have been funny. Find 20 adult ducks, half of which are domesticated, which means they can be around humans and not want to snap at them and stuff like that. And compare their weights. Okay? Now, am I doing something to them? Not necessarily. Okay? So if we're just going to compare their weights, I'm not giving them a drug. I'm not giving them a different food diet. I'm not doing anything different. I'm just seeing half of them are domesticated, half of them aren't. Let's check out their weights. I'm not seeing how do they react to people. Okay, so I've got to pay attention not only to the group, but I have to pay attention to what is it that we're looking for. Okay, to make that determination. Find 300 students, randomly split them into two groups. One group practices basketball 3 times a week. The other group does not practice at all. After 3 months, you interview the students to find out how they feel about school. Okay, now this one just strikes me as strange. It always has when we've talked about this within the department. I don't know how playing basketball has anything directly to do with feeling about school. Maybe it's, hey, this group's involved in an activity and this one isn't. How does that work? But again, some of them are playing basketball, some of them aren't. So, what again are we doing? Now, sometimes there's going to be some words in here that can kind of help us with some things. 5 minutes and randomly split them. Okay? So, we're looking to see, if we want to make a comparison here again. Okay? Are we trying to influence them? Are we trying to tell them, hey, you're going to like school more because you do basketball? Not really, okay? We're not doing something to them. Now, this one, we have arguments every year. And this is one where I would never put this question on a test because I think it's really close, actually. Because I'm putting them into a group. I'm not just looking. So to me, I would call it an experiment. I've had other people that discuss this and they say, oh no, it's an observational study because, you're not doing anything. But one group is practicing basketball, one's not, okay? I've got one group. To me, the basketball group would be the treatment and the ones that don't would be the placebo. So to me, this is an experiment and I'm sticking to that. You're like, Hardy, you could have just said that. But I want you to be thinking the whole time about this, what could my options be? And then finally, you want to know how students and parents feel about school uniforms. Now, to me, that's neither of them. That would be a survey. I'm not splitting them into groups. I'm not watching to see how they feel about it. They literally are just feeling that way. So I just broke my own rule. It's not an experiment or an observational study. It's a survey. Yep, I'm getting slap happy here towards the end. That's all right. This is the only section like this we have. Then I can get back to my strength, which is math here. So, okay, distinguish between correlation and causation. This is much more straightforward. Correlation. When one event happens, the other is more likely. Now, it didn't say it makes it happen. It's just more likely. When the pond is frozen, it's more likely to snow. Why? Well, if the pond's frozen, it's below 32 degrees. So if there's precipitation, it's going to be snow. Makes sense. Causation. One event is the direct cause of the other. Turning on a light makes a room brighter. Well, yeah, if it's dark, I turn on the light, it makes it brighter, okay? One thing makes the other thing occur. So if I didn't turn on the light, the room wouldn't be brighter because there'd be no light in it. You're like, yeah, I suppose. So determine the following shows correlation or causation. Explain your reasoning. Okay. Children who live in very large houses usually get larger allowances than children who live in small houses. Now, is that true? Here's the question I want you to ask on these. Is that true every time, or is that only true some of the time? Okay? If it's true some of the time, it would be correlation. If what I look in the statement is true all of the time, that would be causation. So if kids are in large houses, do they always get larger allowances than children who live in small houses? No. Okay. There are some people I know, okay, even that make a lot more money than me, and their kids get barely any allowance because the parents feel that you need to earn it, not just have it handed to you just because I have a lot. Okay. So no, that's not true every single time. Sometimes people who live in larger houses don't have as much money as the people who live in smaller houses because they make choices, but that's a whole different thing for another time. Studies have shown that eating more fish will improve your math grade. Now, don't we wish this was true every time? Eat some fish, you get an A. Man, I'll make it happen. I like fish, so that's not really true. So, no, that's not all the time. So, again. Now, is it true is it true that fish has shown to start firing off some neurons in your brain more that would give you an opportunity? Yes. Okay, so correlation, not all good math students eat fish. Okay, that would be my reasoning, and I forgot to reason on the first one. Well, I kind of spoke through it, okay? Some kids live in small houses and get big allowances. Or you could even change the word small and big here. Some kids live in big houses and get small allowances or no allowance, okay? But again, the explanation here almost is as important as knowing which one it is, because it's showing that you kind of are starting to get the concept a little bit, even though this is a little abstract, to say the least. All right. If you lose a library book, you will have to pay a fine. I mean, if you lose it, you can't take it back. And if you can't take it back, nobody can rent it. Now I'm acting like it's Blockbuster. Some of you don't even know what Blockbuster is, probably. So this would be causation. Why am I being fined? Not just randomly. I'm being fined because I lost a book, so they can't have it for other people. So I lost book. I pay. I mean, that's just how it works. If you lose somebody's stuff, you pay to replace it, okay? So I lose it, I pay it, okay. Reading a diet book will make you lose weight. This one makes me smile every time I see it, okay? I wish it were that simple. That'd be great. So no. However, that is a good first step. So reading, let's see here. Reading could give me good weight loss ideas. Okay, maybe it'll talk to me about certain foods help increase my metabolism. Maybe it'll talk about portioning things better so I can do that, but it's not going to do it for me. Okay, I mean, there's programs out there where they will help you with the portions and stuff, but just reading the book isn't going to do that. So correlation, it could help me. It's more likely to get me on the right track. Maybe reading the diet book gets me to think about exercise more too, but it's not making me lose weight. Okay, last one. If I miss a day of school, I will not earn the perfect attendance award. Well, duh. Okay. Causation. Absence equals not perfect attendance. That's it. That's it. Okay. And so there's some more of these questions in the stream, of course, but also in the packet here. Okay. And I do want to make mention of something when I come over here. So I went a little more in depth with this, and I should have done this in the notes as well. I admit this. So I'm going to do a couple of the problems here as well. So state whether the situation is an experiment or an observational study. Identify the control group and the treated group. Now, what does that mean? Control group is the group where I don't change a thing. They keep doing whatever they've been doing. The treated group is the group I'm making a change to. Maybe they're getting the drug. Maybe they're trying the exercise program, whatever it happens to be. So, for instance, find 200 people at a mall and randomly split them into two groups. One group tries a new pain reliever medicine. The other group tries a placebo. Now, I would not suggest this to begin with. And anyway, I'm not just grabbing 200 people at a mall and start giving them medicine. What are we doing, people? But again, I digress. So we're going to randomly split them into two groups. Randomly. Okay? But let's look at this. One group tries a medicine. The other group tries a placebo. I am specifically giving one group something that I don't give the other. So if we think back, which does that get us more towards? That would be an experiment. because I'm physically changing something about one of the groups. Okay? The control group would be my placebo. And a placebo, again, is just, hi, I'm giving you this pill, but there's really nothing in it. It's just like filler stuff. And then the new medicine, that would be my treated group. Okay? That's the thought process that we're working through here. Okay? So if I can point out specifically one group I'm changing and one group I'm keeping the same, that's an experiment. If I just split you into two groups and I do nothing, I'm just watching you to see what's going on, that's something completely different. Okay, when we come down here, so let's say we come down here. Oh, I see one with grades. Let's do that. Okay, a survey, an observational study, or an experiment. Explain the process. Okay, you want to see if students who have a 4.0 grade point average study more than those who do not. Okay, I'm not just going to ask people. People can lie. So it's not a survey. I don't just want an opinion. So an observational study or an experiment, well, I'm not going to tell them what to do to get a better grade. So I don't want just their opinion. I'm not telling them what to do. I just want to see. So to me, that screams observational study. So how would I do this? Well, it sounds like to me, so if I'm going to explain the process, pick 54.0 students and 50 below 4.0 students. And record study time for, I don't know, 1 month. It's got to be longer than a day or a week or something. And then I could kind of start to see, are the 4.0 students studying 8 hours a day? Hope not. And the rest of them are studying 8 minutes? Maybe, I don't know. But that's how you kind of just study and look. I'm not telling somebody to study a certain amount. I'm not doing anything. I'm just watching. Okay, and then correlation or causation, I'll leave that because I think that's pretty straightforward. So that is our intro here to stats and probability. We will get more into a little bit more into math, but again, nothing going to be any complicated, and we'll do that the next time I see you.